Space specialists have found using our new $10 billion toy, the Leave Plan, a very long time before that errand transforms into a reality. In case it goes as expected, the trip to Proxima will take about 20 years. So everything thought of it as will be very much as scarcely any prior years we can confirm, accepting there is to be certain life on that planet. The well-established question would be, are we really alone in this universe? The James Webb Telescope has discovered some unearthly, humanesque things far off from Earth, driving us closer to the military reaction. Our journey for life past us has been broad throughout each human development, so much that we have a large number of media composing and theories with respect to this matter. Our supernatural occurrence concerning our place and sadness in the universe has been consistent, as if it is saturated inside us to search for a companion continually. Despite how unapproachable, to be sure, we could really be finding progressively near the arrangements we really care about. Anyway, would they say they are truly the reactions we are looking for, or on the other hand, would they say they are altogether more terrifying? As we research the latest discoveries in the areas of universes and planets on the excursion to find something we might actually not be prepared to notice lights quite far off, analysts have found what could be the most momentous exposure of all time. Back in 2021, when the James Webb Space Telescope was launched, an incredibly interesting speculative request was raised about the limits of our advancement. The request was whether later on our telescopes would be able to perceive artificial light on another planet, for example, Proxima B. Proxima B, the closest exoplanet to Earth, is in the habitable zone of our nearest neighbor, the little star Proxima Centauri, around 4.25 light-years away. Since the exoplanet was on different occasions nearer to its star than Earth is from the Sun, Proxima B was acknowledged to be tidally locked with a supertough dayside and nightside, like our Moon. A speculative creative human progress on Proxima B could move force and power from the dayside to the nightside using photovoltaic cells that produce power out of starlight. Thus, in a paper with Manna Lingam as one of the researchers, it was shown that tremendous incorporation of the dayside by daylight-based chargers could be perceived with future telescopes. Since JWST was additionally evolved, it would allow us to grow our journey for fake lights to habitable exoplanets like Proxima B. As of now, in 2024, it is possible that the James Webb Space Telescope did precisely that. Using its higher responsiveness and more prominent extent of limits, the JWST could have found the lights we were looking for and potentially flung us into another immense surge of human progression on the entire. Let us hop into the universe of planets and exoplanets to sort out how this was even possible. James Webb's focal objective examines Proxima's and Centauri's advantaged experiences over the whole process of things working out. Individuals have contemplated the possibility of the universe. What are we? Where do we come from? Likewise, where do we go? These are ordinary yet very inconvenient requests. Man has endeavored to answer them when he acquired mindfulness. As of now, in the hour of sensational mechanical movement, one mulls over whether we are any closer to any of the above inquiries. If you would ask a scientist, he would most probably say we are right now at level 0 of sorting out ourselves in the universe. However, ask a space master the same thing and watch him skip around in enthusiasm as he hustles to tell you the latest discoveries made about the universe using their advanced mechanical assemblies. These gadgets, yet not given a lot of thought by the ordinary public, are direct signs of human advancement itself. We presently have the world readily accessible, and it is time we push ahead and get the universe readily accessible. Additionally, one such strategy for doing that has been closed by scientists and astronomers. It is through the advancement we harness. A specific creation of that said advancement is as of now responsible for the new discovery of what could be lights on a distant planet light-years away. To be sure, we're talking about the James Webb Space Telescope. The James Webb Space Telescope is the creation considered out of the practices of human missions into space to address a couple of all-time presented questions. Are we isolated from everyone else who is out there? Where do we start and where do we end? Without a doubt, this infrared stargazing instrument has proactively begun answering these requests, but to some extent. To be sure, first you could wind up asking, what even is Proxima B? Proxima Centauri B, or just Proxima B, is sometimes referred to as Alpha Centauri B. It is a super-Earth and it orbits an M-type star. Super-Earths are a class of planets that are more immense than Earth, yet lighter than ice giants like Neptune and Uranus. They are really diverse. They can be composed of gas, rock, or even a blend of both, and their sizes can change from twice the size of Earth all the way to several times its mass. They genuinely put the super in super-Earth. Concerning Proxima B, it is a super-Earth and an exoplanet, meaning that a planet crosses outside the planetary system. The first possible verification of an exoplanet was seen as early as 1917. Regardless, it managed to stir up little interest and affirmation. Nevertheless, in 1992, the first confirmed identification happened, which left analysts shocked. Another exoplanet, which was first perceived in 1988, was confirmed in 2003. As of April 1, 2024, there are 5,653 confirmed exoplanets in 4,161 planetary systems. Out of them, 896 systems had more than one planet. These fabulous discoveries are orbiting an M-type star. To make sense of the M-type star you truly care about, it is essential to understand the red dwarf. A red dwarf is the smallest kind of star in the stellar classification system, which is why it is named that way. In the context of our Sun, red dwarfs are by a significant margin the most common type of star found in the galaxy. They have very low luminosity, and since luminosity is one of our primary measures for planet detection and various types of radiation, red dwarfs are not that easy to spot. The stars have variable definitions and names depending on their temperatures and sizes. For example, M-type stars or red dwarfs have a maximum temperature of about 3,900 K, which is why they get their name and characteristics. Getting back to Proxima B, its mass is known to be similar to 1.07 Earths. Peculiarly, it only takes 11.2 days to complete one orbit of its star, compared to our 365.25 days. You can check the size of the star Proxima B is orbiting. Remarkably, under the entire electromagnetic spectrum, the star has a total luminosity of just around 0.16% that of the Sun. Additionally, in the visible light spectrum, its luminosity seems to dim even more. It only emits 0.056% of the Sun's luminosity in the visible light range, emitting a generally lesser amount of light energy compared to the Sun. More than 85% of its emitted energy is in the form of infrared radiation. Proxima B is, in particular, the closest known star to our Sun and, by definition, to us. But 4.2 light-years is a significant distance for us Earthlings. In the grand scheme of the universe, it is a mere blip. So why Proxima B, our closest known star, is high up on the priority list? At this moment, it is also part of the Alpha Centauri star system. Despite Proxima B's luminosity being remarkably low, the actual system appears as one of the most notable star groupings in the night sky, just behind two others called Sirius and Canopus. However, the most fascinating thing about Proxima Centauri B is that it potentially lies within the habitable zone. The possible results involving the star are endless, and thus astronomers have taken on the task to examine the depths and limits of the star's potential. That is where the James Webb Space Telescope comes in. As the JWST continues its examination of the said exoplanet, we get progressively closer to the fulfillment of these missions, from SEI to exoplanet searches for extraterrestrial life. So what exactly is SEI? Considering that humans have always been curious creatures, seeking to explore everything that moves and even what doesn't, it is logical that a project like SETI emerged on such a grand scale. Imagine that we have been tasked with searching for signals, even more specifically electromagnetic whispers from civilizations beyond our imagination. SETI is short for the Search for Extraterrestrial Intelligence, and it is our ongoing work to recognize signs of intelligent life lurking among the stars. Our interest dates back to the early 1900s. Not long after radio technology came into human use, visionaries like Nikola Tesla and Guglielmo Marconi conceived the idea of using these novel devices to make contact with the stars. Indeed, Tesla even fancied the idea of communicating with Martians using his wireless transmission system. Fast forward to the swinging 60s, and we find ourselves amidst Project Ozma, the brainchild of the visionary astronomer Frank Drake. Armed with a powerful radio telescope and a strong piece of interest, Drake sifted through the cosmic radio waves for signs of something happening beneath the surface. Tragically, his efforts did not yield any results, but the quest continued. Scientists around the planet kept tuning their radio antennas to the galactic conversation, searching for extraterrestrial chatter. Meanwhile, across the Iron Curtain in the Soviet Union, our friends were also engaged in similar efforts. Driven by the renowned ISF Shklovsky, Soviet scientists turned their radio antennas skyward, hoping to catch those elusive transmissions from the stars. The stage was set for an extraordinary showdown. And then, what's this? A peculiar signal pierced through the vast noise, raising the excitement and nerves of astronomers to an all-time high. This signal, known as the WOW signal, sent shockwaves through the scientific community. As the years progressed, the search for grandiose alien messages continued, leading to the ambitious Cyclops project. Scientists went all out in their quest to unravel the enigmatic secret. In a fortunate twist, or perhaps by fate, a coded radio transmission from Mars graced our Hubble telescopes, reigniting our interest. But what does this examination really look like now, and how far have we advanced with respect to searching for signals from Proxima B? In a 2021 study titled Detectability of Artificial Lights from Proxima B, experts Elisa Taba and Abraham Libb aimed to explore the potential for detecting artificial lights emanating from the obscured side of Proxima B. Since Proxima B is a planet located in the habitable zone of its star, the review aimed to determine whether Proxima B might support intelligent life and how to detect it. Following Proxima B's significance as a target in the search for extraterrestrial life, they developed an intriguing yet somewhat unsettling nuance. A new speculative radio transmission detected from Proxima B's direction. Although it wasn't recent, being captured some time ago, when your field of investigation is the vastness of space, where data takes years to travel, every discovery is a significant leap forward. This has generated a tremendous buzz among the scientific and astronomical communities. The speculative radio transmission added another layer of mystery and excitement that astronomers are eager to unveil. The transmission was identified by the Breakthrough Listen project and represents a potential candidate for an extraterrestrial radio signal originating from the vicinity of Proxima Centauri, the host star of Proxima B. The Breakthrough Listen project, initiated in 2015, is designed to survey the sky for signals indicative of advanced technological civilizations beyond Earth. Using state-of-the-art radio telescopes and data analysis techniques, the project searches the electromagnetic spectrum for unusual transmissions that cannot be easily explained by natural phenomena. This search has been ongoing, and the speculative radio transmission from Proxima B is a noteworthy discovery. Astronomers managing the project identified a narrowband signal at a frequency of approximately 982 MHz. This frequency falls within the range typically associated with artificial radio transmissions on Earth, such as those used for communication purposes. While the notification sign has not been definitively attributed to an extraterrestrial origin and may have alternative explanations, the discovery remains a significant milestone in humanity's quest. The Breakthrough Listen team conducted follow-up observations and data analysis to investigate the signal further. The goal was to assess its likelihood of being of extraterrestrial origin. Although definitive conclusions are currently elusive, the vast expanse of space is not as fundamentally inhospitable as we once thought. 1,000 complex variables and interference from natural sources can and will distort the results. Scientists cannot advance with imprecise results, as space missions require meticulous precision and substantial funding to execute. Even minor errors based on ambiguous responses are unacceptable. The quest continues as we strive to unravel the mysteries of the universe.